Bernie, I have it covered. So. Yeah. Okay, so it's full hour, so let's get this going. Welcome, everyone. This is a DHC working group meeting. So if you are looking for something else, you are in the wrong room. Oh, I thought the first guy was leaving already. Okay, so note well, you probably are familiar with this one, so we can skip it. Yeah, so you know the usual drill applies. So please sign the blue sheets. We need JavaScripts. There's Etherpad, so if you can contribute to taking minutes, that would be great. And the chairs hasn't changed in a while. So I'm Tomek Mrugalski, and
I'm Bernie Holtz.
So this is the agenda that we have for today. So administrative, this is what we are going through right now. The next one will be a refreshment from Bernie about link layer address assignment. This is something that's been presented previously, but it's been a while, so it's good to have a refresher. And after that, there's a new presentation from Carlos about a related topic, so which slab quadrant selection to use for link layer address assignment. After that, we'll have a remote presentation about Young model for DHCPv6. So this will be done remotely by Ian. I hope he will make it, because if not, I am the backup.
He is online. So.
Okay, so that looks good. And then we'll have probably the most important part of this session today, which will be a discussion about future of the working group. And after that, we have a presentation about another draft that's been around for a while. It's about multi-requirement extensions for DHCPv6. So that's pretty much it. So any comments?
What's the question? Moving the 6 before 5.
Yeah, so we decided that this is the most appropriate order, because we wouldn't want to have the future of the working group to be the last, because we kind of estimated this will take 15 minutes, but it might take much longer. So, and this is essential topic for the working group, so we don't want to rush it in any way.
Yeah, and also the that last draft, the problem statement, is also just an informational document, so it's not as critical as protocol docs. So, all right. With that, I guess I'm up. Hold on a second. Let's hope it gets the latest. Okay. There's a clicker here somewhere, right? Yeah, there it is. Let's see if it works.
Does it? No. Okay. So I will be on.
Yep. No. Okay. All right. So, can you advance? So a little background on this, because it has been presented before, and we did try to do a working group adoption call. But the background on this work is that there is a cooperation defined between IEEE 802 working groups and the IETF. And a while ago, the IEEE split up the local MAC address space into 4 quadrants, and there was a working group within the IETF established to work on defining an allocation mechanism for those 4 quadrants. You know, half the address space is managed by people purchasing, you know, typically manufacturers purchasing a interface identifier, an OUI, what is it? Organizational Unique Identifier, I think is the name of it. So, you know, typically the first 3 octets of the MAC address, and the rest of the address space, the second half, was sort of undefined. It was, you know, usable by anybody, and this is what they split up into 4 quadrants to make it a little bit more manageable as to how the usage happened. And they wanted, the IEEE is looking for some algorithms to allocate that address space to devices, and it was supposed to be much more dynamically allocated, sort of, you know, and so it's a little bit like DHCP in that you probably would lease an address for a period of time, and when you're done, give it up. And that's what caused Routh, Droms, and several others thought that DHCP might be one of those possible ways of allocating this address space to either clients or hypervisors or any other devices that needed blocks of MAC addresses. So Routh contacted me, and Tomek and I discussed it a bit, and we decided to work on publishing a draft, which we did. If people are more interested in details about what IEEE is doing and what they're looking for, there's this presentation that Pat Thaler did back in at IETF 96. That's a very useful slide deck to look at. We also, Tomek and I presented this at the IEEE RAN meeting in late May. We did this remotely. We didn't attend. And then we did a call for adoption to the DHC working group, which failed in January of this year. It was like an adoption right over the New Year time period and stuff. Next slide. So IEEE is still very interested in us pursuing this. They are working on some other allocation algorithms that, or protocols that are much more sort of at the link layer, but they see that the use case that we were kind of focusing on, which is more the hypervisor or VM manager that might need to assign lots of MAC addresses to, you know, each of the VMs that it produces, was a good model for DHCP. It could be used by individual clients as well to get MAC addresses, but it was primarily for devices like hypervisors. So, you know, this was, I contacted one of the key people I was working with around the IEEE work, and they are still very interested in us doing this work. And so that's why I'm back here trying to hopefully get people more interested in it. Continue. So, you know, the primary use case that we're focusing on is a hypervisor where it needs to allocate you know, may have lots of virtual machines that it produces over time that it needs to allocate MAC addresses to. You know, some may have very short life, others may have very long life. And the idea generally would be that this hypervisor would get a block of addresses at once, dole them out. When it needed more, it would go back to using DHCP to get another block of addresses. Again, it could be used for IoT devices as well, or individual clients, but that's a little bit harder model because, you know, it's a bootstrap problem because the devices don't, if they don't have a MAC address to start with, how do they do DHCP v6? You know, we do have a description of how that could be done. You know, why DHCP v6? It has all the existing infrastructure that we need. You know, we've got a protocol, we've got the network tools. The server already knows how to manage and allocate resources. The protocol is designed to be easily extensible, and we're also in the DC working group. So, next. I kind of covered all this, so let's go to the next slide. So, the way that we proposed doing this was to find two new DHCP v6 options. One is called the Identity Association for Link Layer Addresses option, and it's very similar to the IANA and IAPD. It is used as a container for the options to request link layer addresses. The LLADDR option is the link layer address option, and that carries the address, and it's similar to the IA address and IA prefix option. Next slide, please. Ooh, I kind of squished it all. That's pretty bad in the conversion. So the option is very similar in that, you know, we have an IAID and we have the T1 and T2 times for the renewal and the rebinding lifetimes. So it carries the, you know, can carry additional options, which are the LLADDR options to hold the individual address assignments. Next slide. Yeah, it's kind of got squished, but the link layer ADDR option has in it the link layer type, the link layer length, you know, which in most cases would just be the Ethernet values, the link layer address that was either requested or assigned, depending on which way the option is going, and the number of extra addresses, because the default would be just to give a device one address, but the idea could be that either a device could ask for a large block, you know, hundreds, thousands of addresses, or the server can assign it some number of addresses at once. And these would be contiguous addresses, you know, so it's a block of addresses. We didn't do it like prefix delegation, where you have to always do stuff in powers of 2, because we didn't think that, you know, that would be the best way to do the allocation. Instead, you know, so a device can ask for 100 or 1,000 or whatever it wants. And there's only a valid lifetime provided. There's no preferred lifetime, because that's really up to the hypervisor or who's ever using this to figure out, you know, how do they want to treat this, because it's you know, it's a link layer address. It's not like a, you know, a IPv6 address where you might want to use it for a time period and only use it for you know, use it for new connections in the preferred lifetime, and then use it in sort of only use it in existing connections when it becomes deprecated. You wouldn't want to do that for link layer addresses. It doesn't really make any sense. So we removed the preferred lifetime from that message. You know, the algorithm and the protocol works exactly like it does for address assignment prefix delegation. The client sends a solicit with this set of options, and it'll get advertised, and it sends a request, and then it gets a reply. It can be renewed. We did simplify things in the sense that it really doesn't make that much sense to use confirm, decline, or information request messages related to this, although, you know, the information request doesn't really come into play here. But the confirm and decline are not really used, because how do you, there's no way to test for, you know, is a MAC address already sort of in use at the MAC address layer, so we didn't think that was necessary. So in the hypervisor model, the hypervisor is the client, but it doesn't use the resulting link layer addresses. It instead assigns it to VMs as it creates them, and it typically will get a large block. And, you know, the VMs then can do standard DHCP once they get the MAC address. Next. If an end client wanted to do this, it could use a temporary MAC address. And again, it's kind of gotten squished off the screen here, but, you know, let's see, clarify client must not use based on temporary MAC. Yeah, so that was just, you know, we think that because it's you know, a client typically generates its DUID based on the MAC address it's got. In this model, you wouldn't be able to do that because you don't have a permanent assignment for the MAC address. Next. So again, the question is this work of interest to the DHC working group? We did fail the call for adoption. The IEEE would like to see this work progress. You know, the question is, should we try for another call for adoption? Are we going to get anybody more interested? Carlos will also discuss an extension to this so that the hypervisor or client can request which block of addresses, you know, which quadrant of addresses it would like a MAC address from. So comments at this point, questions? Anybody have any? Oh, okay, Francis.
Yes, Francis Dupont. Just a question: why the call for adoption failed? Just not enough response?
We had exactly 0 responses.
Ah, not enough response.
Yes, nobody complained, but nobody, supported the work.
So there are 2 supports, the 2 offers.
Yeah, well, and the 2 people that supported are the working group chairs. So it's not. Yeah, well, we would like some additional input. Yes.
Tim Chan, was there any, in those collaboration meetings, was there any alternative proposed, or is this the one that everyone would like to do from that collaboration meeting?
So you mean from the IEEE side?
Yeah. You said you had a meeting in February or somebody. So there was some...
Yeah, I didn't. That was actually the IETF coordination, IEEE IETF coordination call where that was discussed on. And Max, who I've been dealing with, is the one that made that comment saying, yes, IEEE, the RAN group still wants this work to progress. Okay.
I guess phrasing it another way, if for some reason this working group refuses to run with it, what would be the alternative? Yeah,
I think they would have no alternative at that, at sort of the higher level. They are working, and I don't know, he didn't point me, I kind of said, is there a document that talks about how you guys are planning to do this at the MAC layer or something? And he didn't point me to a document that exists for that yet. And in the notes I found about the IEEE meetings, I did not see anybody, comment specifically on, we have this new protocol that we're working on.
Okay, thanks.
So I think it's still a work in progress is the short answer. Oh, Suresh.
Suresh, go ahead.
There's a button to click on, the red one. Yeah.
I'm afraid to push the red button.
Okay, hey Suresh, we don't hear you, and you send me something over Jabber. He said, Suresh, with AD at off, he supports this work.
Okay. Thank you.
Eric Klein, a question about also about the collaboration with IEEE. Did they say anything about wanting a prefix style allocation of large blocks? Because if you did want 1,000 max, that's a pretty big set of messages.
Did they say anything about?
Did they have a feeling or express an opinion one way or the other about you said you chose not to do MAC allocation by prefixes
by powers of 2.
By powers of 2, right? Yeah.
Yeah.
Did they think that would have been useful? Are both options useful?
We never really discussed that. We presented it and they seemed fine with it.
So
I suppose it could be added later if it was an issue, right?
Yeah, right. Or you could just say, you round up to the next power of 2 if you wanted on these extra addresses, right? I mean, you could do it. A server could always employ whatever policy it wanted to enforce.
So with this approach, it's more flexible. You can do powers of 2, but you can also do small chunks if you want to.
Yeah, but I mean, well, you can powers of 2. You're handing them out individually in the messages, right?
No. The message defines the first address and the number of addresses that follows, but those addresses are never sent. So
I read that as
no.
repeated set of.
No.
Okay, that makes sense. Thank you.
Again, in the name of Suresh, I guess with his AD off, he said, as far as I know, there are no alternatives from the IEEE side on this proposal.
There's not enough, sorry?
There is no IEEE proposal on this side. No alternatives, sorry.
I think, I didn't find anything concrete, so I don't know that there really is anything else that they have at the present time. But they did, when we talked to them back in May of last year, they did want to do a MAC layer, because this runs over IPv6, right? And so there's a lot of stuff you need to get going, and you need a MAC address to talk. So they're trying to work on something that would work at the MAC layer.
I'm Jim Mehta there. I've read this document and tried to respond to the adoption call. I didn't see any technical problem about it, but the usage, intended usage seemed to be bit hypothetical. So I was not sure how to respond, and that's why I was basically silent. And I guess many other people probably did the same thing. And if there are really people interested in it, probably they should speak up. Then we can probably move forward. If, for example, if the document is adopted, I'm happy to make a fairly technical review on it.
Yeah, and I think next time around, I have to, if we do for another call for adoption, I think we're going to have to make sure that the IEEE folks speak up.
Tim Tan, just for clarity, is the use case for a device that's already using a MAC address is on the network to request more for VMs or tethering or whatever local networking use case it has within itself, I guess? Is that thing, or is it to actually allow MAC addresses to be requested for a node that's starting up in some way? Well,
I mean, there is a way. We did document how a individual device that wants a MAC address that was more longer term assigned, could work, but we don't know what it is kind of a contrived case because we don't, we don't really have a good answer for that, right? Okay. The hypervisor stuff is much easier because it's already
that's a clear use case that solves an existing problem.
Yeah, and like the IoT use case of having the sensors sort of get a long-term address. We don't know whether that maybe Carlos has a little bit more on that. So maybe we should wait to sort of figure out what we want to do based on his presentation as well.
Okay, that makes sense.
So with that, I think let's turn it over to Carlos.
Well, you can try.
You need to
this one here? Get to page? Okay. And then there's a little arrow there with a piece of paper that says push.
Okay, so I'm Carlos Bernardo from UC3M, and I'm going to present this document that is kind of a complement or extension to what Bernie presented before. So in the background, most of it has been already summarized by Bernie. I just want to provide a bit more details on how IEEE has structured this local addressing space in this what they call this structure local address plan SLAP. And they had divided that, so the local addresses space, in 4 regions or quadrants. One that is called the extended local identifier, which basically they have a company ID, and then that it uses 24 bits, and then the remaining 24 bits can be used for assigning addresses for that particular company ID. So this is basically to assign local addresses based on a kind of vendor kind of thing. Then they have another quadrant that is called a standard assigned identifier space, which is supposed to be managed by protocols defined by at IEEE standard. And in that case, there are 44 bits available for assigning addresses. Then there is another quadrant that is called administratively assigned identifier, in which they don't specify how the addresses are assigned for that particular quadrant, so by an administrator using whatever mechanism. And then there is another quadrant that is reserved for future use, although can also be used kind of similarly to the previous quadrant, the administratively assigned identifier quadrant. So those are the 4 different regions that have been defined by IEEE 802C for the local addressing space. Here is basically how this is, how they divided and identified the different quadrants. So you can see at the top of the slide the four first bits of the MAC address. You have the one that identifies if the MAC address is unicast or multicast. Then you have the bit that identifies if it's global or local address. And then the following two bits are used to identify the actual quadrant for the MAC address space. And based on the combination, you have the four different quadrants that I summarized before. So the motivation kind of problem statement of this document is basically complement the work that is being done in IEEE, that is defining the mechanisms to assign addresses in the side quadrant. This is what is being done in EO2.1CQ. Then there is also work here at IETF, as Bernie just presented. And in this document, what basically we do is complement this IETF work part by defining mechanisms that allow to specify or to convey preferences on which kind of quadrant the addresses must be taken off to assign the addresses to the client or to the relay. Why this is required? Well, this is what I will try to explain, summarize with some use cases in the following slides. Basically, this motivation for having the need of specify or provide the preference on the quadrant. So we have different scenarios. Actually, let me see. Okay, I pressed twice the button. So different scenarios depending on whether we are providing addresses to a terminal or to a hypervisor, like Bernie defined before. So let's start with the terminal kind of a scenario. We have Wi-Fi terminals. Those terminals have interfaces that come with some kind of burn-in MAC address, typical situation nowadays. And in some cases now, there are the requirement or the need to assign local addresses to those devices that will replace that kind of temporal MAC address. We have identified two scenarios, but there may be more. This is just this motivation just try to identify the need for this slab quadrant selection, but there may be other scenarios that require that. One is what we call the Internet of Things, the IoT scenario, in which basically you have devices that may come with one address, but you need to assign a local address because there may be so many of those devices that you actually need to do this kind of thing. In this scenario, again, it's an example. Devices are not typically moving, but there may be other scenarios in which they are. And based on that, we discuss in the draft that the quadrant that would be more suitable for this is the LI or the SI. Based on this, for example, maybe there is a need for the IoT devices to use a MAC address based on a kind of vendor company ID, these kind of things. This one example. Another example is what we call the privacy for the Wi-Fi terminals. Is now well known, and it's also an effort in IEEE that in order to mitigate the privacy leaks or the privacy threats by leaking the location, tracking your location based on your address the address that you are using, there is a need for changing periodically or upon an event like connecting to a network the MAC address that you are using. So it cannot be really that obvious that you are here now in Prague and maybe tomorrow we are in our home country by looking at the MAC address and tracking that. In this case, devices typically are mobile, so that's why you want to avoid this tracking. And in this case, the AI quadrant probably is the best because it's the one that allows to make use of more space and to distribute the handle of the MAC addresses and to basically make easier to randomize the address that you are using for that. Then we have also the hypervisor data center scenario, in which we differentiate two different situations. Basically, a hypervisor is getting or requesting addresses to be used for a virtual machine. But this virtual machine may be a virtual machine that is not expected to move from the actual host server where it's going to be instantiated. But there may be situations in which you may forecast or foresee that virtual machine may need to be migrated to another host, another data center, or another server in the same data center. In this case, in the case that you may want to migrate a function, this may need the context of the function to be maintained, and part of the context may be the MAC address that you are using. So again, in the draft we discussed what is the best quadrant for this situation, compared to the scenario in which the function is not expected to move at all, and then you can use a different kind of quadrant that facilitates operationally the way the address is allocated. For example, using AAI quadrant that, depending on the scenario, and we are assuming here a large deployment in a data center, you may want to use AAI to facilitate the assignment or the management of the addresses by splitting or having multiple pools, and you can manage those independently without any coordination, as compared as the case in which you may want to migrate the function and you may need to avoid address application if the function, if the virtual machine goes to another region with another pool of addresses. Then, this is basically a summary of why we need this need for explaining or conveying the preference of the quadrant. Then how the quadrant selection will be done, well, this is not in the scope of this draft, but in the draft we defined or we provided some examples. Like, okay, we have imagine that we have the mechanisms to convey or to include the preference of the quadrant. How we will be selecting which quadrant? Well, for example, we take the IoT scenario. The client or the network combined with the client may have or may use different parameters to guess what is the best quadrant. For example, the type of IoT deployment, if it's a small one, a large one, if the device is going to be moving or not, if the device is managed or unmanaged, if the device is on battery or not. Depending on this, there may be different scenarios. We don't go into the details, but these are things that can be used to decide which preference, which quadrants you wanna use. In the case of a Wi-Fi regular device, well, in this case, the need of privacy or location tracking mitigation or not may be something that you wanna need to consider in order to select which is the best address that you wanna use. And in the case of a data center, the hypervisor might be interact with the cloud management system, like whatever you are using, OpenStack or whatever, or the virtual infrastructure manager. We use more NFV terminology to know if the function that you want to spawn, instantiate, is expected to be migratable, moving or not, and based on that, select the best preference. So this is kind of the motivation. Then we define in the document some extensions to the previous mechanisms defined presented by Bernie. We have here the example figure for a client selecting or conveying the preference to get an address from a particular quadrant. In the draft, we also define the signaling when there is a relay doing this. And basically, in order to do this, we define a new IA LL option for conveying the preference. So basically, the option allows to identify one or several quadrants and an associated preference to that. So the server can get that, and based on that, assign the best address trying to meet the preferences conveyed by the client or by the relay. And this is a short summary of this document. It's a complement extension for the previous document presented by Bernie. So question is the working group interested in working on this? I guess the response is very much related to the former question. If there is no interest in working on the other document, there will be no interest on this. And if there is that also something interesting to look at? So we are, of course, we will be very happy to get any feedback on this on the mailing list. And that's it. Thanks.
Yeah, or any comments here, if anybody has any. All right, so I guess we're back to the original question that, should we try for another call for adoption on either one or both of these? It might also be, appropriate to merge these documents into one, either, after the call or.
Tim Winters, UNHI. Well, I think we should. I'm in support of these documents. I would keep them separate, though. I think they have different functions, so I would leave them as two separate documents. But I would kind of try to advance them at the same time.
Yeah. Okay. Thank you.
Tim Jones, just another voice to say the same thing. I think we should have another go at adopting it. I don't think it failed last time. It wasn't refused. It just didn't get enough
It didn't get enough interest.
Yeah,
yes.
but we cannot assume silent support, so it would be like
yeah. Maybe in true Brexit style, we should have a series of indicative votes to decide what we want to do. I wish I hadn't said that. So yeah, I agree that we should try again, and we should keep the documents separate, because it seems the second topic, there's a lot of subjective things in there, whereas the first topic is much more, just a protocol spec.
Okay, thank you. Sorry? Okay, so Suresh also supports making another pass at the call for adoption. So we will start the call for adoption shortly after the meeting. So look for it, and please do respond.
Yep. Okay, so moving on. The next one is young update from Ian.
Good morning. Can you hear me?
Yes.
Ah, that's seamless, isn't it? Do you have the slides up? I can't see them from here.
Yeah, we're in the process of loading them. Sorry. This is a little. Okay, so now we hit this up over here. There we go. Let's hope it works.
I'll just wonder if I can see them as well. Yeah, okay, I've got them. Can we go to the first slide then, please?
Yep, you're on the first slide.
Then the second slide.
Oh, this one, second slide.
I can't see the numbering. Okay, so this time last year was the last time we did an update on this. There's been a couple of updates since then. Not huge things, but there's been some reviews from mainly from the chairs and from Francis. We've opened the issue tracker as proposed back then, and there's a fair bit that's been done on there. There's still 15 items which are open, some more severe than others. Can I make a request at this stage? If you've opened anything on the issue trackers, there have been updates and sort of attempts to resolve some of these things. So could you review those again and just sort of see whether the changes that are proposed meet what you've raised, or if you've got any other comments that need to be addressed in there as well, that would be welcome, please. Next slide. Okay, so one of the comments that came in from, I think it was the ISC work on implementing this, was that we were lacking any configuration for storing leases and managing that side of things. Obviously, this stuff is not written in any standards documents anywhere, but it's necessary for a DHCP server, so it makes sense to have some kind of generic functions or ways that we can talk to common implementations in order to get that part of things working. So we've added stuff from that, which I think was mainly lifted from the ISC implementation that was done. There's been some other small cleanups as well, but nothing too major in there. But those are the main changes since 06. Next slide, please. Right, so I'll come on to the main problems with it in a second. But really, where we are at the moment is that we've had a real lack of activity. We've got about 5 authors listed on there. I believe I am the only person who's still even got any interest in doing this. I think most people have moved on, either because their courses have finished, or they've changed their roles or whatever else. So this is one of the major problems with getting the thing done. I already made the comment about if you've raised some comments in the issue tracker on GitHub, please can you have a look through those? So I'll reiterate that. There's also, as I mentioned, the ISC Kia implementation. Some real worthwhile stuff there, and we've been looking at it from here and within DT, and it looks like there's something very promising there. I said this to Tomek yesterday, but it would be really good if we can try and sort of fold in the work that they've got there, take the learnings from it, update the model in the draft accordingly, and I think this is going to give us a much more worthwhile and road-tested model to work with that will hopefully get published. Okay, next slide, please. Right, so yeah, as I mentioned, I mean, the lack of authors and work that's gone in recently, it feels like we're kind of starting to languish a bit. From the milestones, we were meant to be ready to go with this by the middle of last year. I think we're still a little way away from doing that. And one of the things that I've noticed on this when I was looking at this earlier this year is we've got a scope that's just probably unachievable as it stands at the moment. So, you know, a combination of lack of authors and scope which is too large means that it's unlikely that we're going to have anything that's kind of ready to publish anytime soon from where I'm looking at it at the moment. Next slide, please. Okay, so my earth-shattering proposal to the lack of authors is to add new authors. Yeah, I spoke to Tomek yesterday, and it seems that there may be a guy from ISC who's willing to join us, which would be obviously more than welcome. If there's anyone else in the work group who's got any interest in this, then please don't hesitate to get in touch and you know, get involved, because I think, you know, if we probably just need 1 or 2 extra people who've got some time to spend on it, and it would be enough to kind of get it over the line. So please, yeah, if you've got any interest, then please get in touch.
So do we have any volunteers in the room besides Michał, who already volunteered? Don't be shy.
Well, let's see. Maybe we'll go back around after we see the other approaches.
Okay.
I think there's more, right?
There's one more, yeah. Next slide. Okay. Obviously, reduce the scope. So, yeah, we've got a boil the ocean problem. We've also got the fact that, yeah, as the protocol, okay, it's not growing as fast as it has been historically, but is still continue to extend. It's, you know, it's getting further and further away from us. So, the proposal here is really, can we de-scope this to a point where we can get something which is useful to be implemented as spec'd, extensible, and, you know, and one of the things that I would suggest here is that we add maybe an appendix which would describe how to extend and to add things in as is necessary in the future. But yeah, I mean, if we can cut it down to the point where we just, you know, have enough to be useful and a framework to build on, then I think we've got most of the stuff there already written, and, you know, the exercise would be much more about cutting down the unnecessary de-scope stuff, you know, tightening up what's in there, adding this appendix, and we should at that stage be ready to publish. So, you know, a combination of this and hopefully the addition of another author or two, then I think we can get to a point where we've got something ready to publish fairly shortly. If we decided this is what we want to do, then obviously we would need to discuss what we think would need to be in scope for you know, the updated draft. Any thoughts on this proposal about well, if this is a good idea, and if so, what should or shouldn't be included?
Yeah, Bernie Volz, working chair hat off. I kind of think that, you know, it might be interesting to look at the way the DNS ops group is going about it, where they're sort of starting to define stuff more along, you know, what's in the IANA registry. So they're starting to define the, you know, the resource records and things like that. And maybe that's something that, you know, we should think about here, is maybe starting a little bit, you know, more about having a standard way to represent the options and other data that is DHCP stuff. Because part of the problem that you know, because we did this same sort of work many years ago to try to do an LDAP model, and the big problem is that, you know, especially for the server parts, you know, and potentially even clients, but you know, I know the server better, kind of, and the issue there was that servers are designed to, you know, take configuration models in a different manner than like the ISC, you know, and Kia probably differs from the original ISC server and stuff. So if you try to produce one model, then you kind of have to follow one server architecture or configuration model, which doesn't necessarily agree with other servers. So one thought might be, you know, if we sort of build a common building blocks that people can put together to produce specific models for their server clients relays, that might be more useful than trying to say, oh, here is, you know, the standard model to use for everybody. I mean, it's just an idea that we could, you know, sort of start with the fundamental building blocks that people could then use in their Yang models. It's not as good as if we had a standardized Yang model, but again, the problem is that, you know, the configuration models for these things are just different.
I mean, I understand your point. A while ago, we split out the option definitions into being a standalone module that gets referenced by client-server relay wherever necessary. I mean, as part of doing that work, one of the things became apparent is you can't just go right through the IANA list and make Yang module for every single one of them. Well, you can do, but you know, when it comes to some of these things, there's just kind of no point. You know, an IAPD, for example, is constructed by a client, and it builds that based on the protocol specifications rather than anything that's Yang relevant. I suppose you could reference that as state data to see, well, what is it that it had built? But you know, it's of minimal benefit at that stage. So I mean, I think we do follow this approach to some, well, wherever it's kind of logical to do this. It's just, you know, to some extent, I wonder, without having the ability to configure the machinery behind making those options work, whether there's much value in it in some cases. In other cases, it does work. In some cases, I think it doesn't. To your second point, I mean, yes, I understand the implementations are different. Concepts, though, are fairly uniform. And, you know, one of the things that I had hoped that we would be able to do through the authoring process is get the input of more than just one implementation to be able to say, well, if there are, you know, where are those differences? Where does this module no longer function for those? And is this stuff that, you know, they're just so different we can't possibly find a commonality here, and it's not, there's no point in trying, or is it possible to come up with something that works for both? And, you know, that would be really useful input to have as based on another real or one or more real implementations in order to kind of, you know, find out if that's something that we can do.
Yeah. Well, and just to respond quickly to your, you know, I don't think that we have to model, you know, maybe I misspoke to say all options. It's just, you know, those that are configured right in entities that you need to worry about, you know, the IANA, you know, those kind of things that go over the wire and are just designed for the wire stuff. I don't think we have to really.
I mean, I guess my feeling there would be basically you create, you know, anything that you can submit in an information request would be modelable in that way. Okay, I mean, it may or may not be better than nothing.
It's a little more complicated because, you know, there are things like, you know, even things like the prefix exclude step, right? You have to have a model to configure that for it to be sent. So, yes, you know, and so I think it is an interesting problem, and it's not as simple as just sort of taking the stuff and mapping the text or the diagrams into the Yang equivalent, because, you know, you have to really think about what you're doing, because, you know, you have to convey the right information so that it can be used properly. So, but I mean, yeah, I don't know. I mean, this has always been the problem with these models, right? Is that there's different ways of slicing and dicing how they're sort of put together and stuff. Maybe, I don't know whether, let's let other people talk and see.
Tim, so I was just going to maybe draw a parallel to the way the Yang models or modules have been defined for router advertisements. So there is a base module, and there are certain options that aren't included in that. The last time I looked a year or two ago, there was no way the DNS resolver option wasn't something that you could do. So I guess the question, and all for reducing the scope, I think that's a pragmatic way of getting something out. I guess the question is it then going to be useful to someone if you're producing something that's of reduced scope?
Yeah.
That's I think the big question.
Tomek Murgowski, ISC. So 2 comments. First, Ian, you mentioned that there's a difference between the Kia young implementation and the one that is described in the draft currently. I would say that there's flexibility on two sides. The implementation that we did in Kia, this was done under tight schedule restrictions. So we did what was the easiest for us, but our model is not fixed in stone. We can adjust it, and the long-term goal is to follow whatever is in the draft. So, and the second comment is I agree with Ian that it's, in my opinion, this is possible to define a model that represents a generic, like, common denominator of all implementations. And I feel that if the model describes more features that specific implementation implements, so be it. You don't have to use all the parameters in the model, right? So I still hope that it's doable. But having said that, if for whatever reason we are not able to proceed with this approach, what they are doing in DNSOP would be the last resort, you know, just to pick the bits and pieces that people could use in different ways. Yeah, I would definitely prefer the way to go the way the draft is trying to do now, which is to define the full model.
Well, and just to interject there, I think you can do both. You could do both, right? You could start on the, I mean, there's a lot of stuff already there that could probably be published as it's less controversial or less, because it's sort of the option definitions, things like that are pretty straightforward, right? And so that could be published potentially and used by people, and then you could still work on the second part, which is to put more of it, even more of it together. I don't know. It's just one approach.
I mean, yeah, certainly we could do that, and the way that when we divided up and created a separate module just for describing options in there, certainly, I mean, that could be split out into another draft. And I mean, we would need to get, I think, define our scoping first of all, just to make sure that that's what we have there is useful, and it is defined in a way that makes it easy to reuse based on whatever we would do in the server relay client models as those progress as well. But I guess it wouldn't be a case of saying let's just publish the options first and then worry about what to do with them later on. We would have to work at the different modules in parallel.
Richard Patterson. I just kind of like to reiterate I guess the idea to focus the scope of this work into the common areas where it's required to get this running. I think extending it out, and I think to Bernie's point around trying to capture all possible permutations and even vendor implementations is going to be quite troublesome. And even from a network element modeling point of view, I think I've personally resigned myself to that. We're always going to have vendor-specific YAG models. I don't think we're ever going to be able to capture everything that we want to do in common IETF-defined models. So I'm just, from a network element point of view, I think we're always going to have custom proprietary vendor-specific stuff. So I think leave it up to them, the implementations, if they want to do some weird and funky things.
Yeah, that's sort of where I'm, because if you define like building blocks about, well, this is a prefix, right? And these are the basic things, you need the prefix length, you need this, and stuff. And then people can, they can extend that to add all their custom configuration stuff that they may have and stuff. Because they're going to do that anyway. You have to do that anyway. And so and putting the model together is also, putting all the elements in how they are configured or organized sometimes is a problem as well, because that's done differently in different configurations or different server implementations or client implementations.
I mean, what I would hope to see in that case is that, as I mentioned, that the building blocks of and the terminology and concepts around how we configure populated a DHCP server are pretty common. So a model that allows you to do that and can be as much as possible implementation agnostic, I think is what I would like to see. Something that is also augmentable with whatever vendor specific features or customizations that happen to be in there that I may wish to take advantage of, I may not wish to, but those are things that get applied on top of the standardized skeleton. And from what I'm seeing, what I would like to do is get this skeleton, and that's what I think we can do. I mean, Bernie, from your perspective, do you see anything in the model as it stands at the moment that would mean that that's not possible?
Yes, I'd have to go back and look at it because it has been a while since I did take a serious go through it. So I'll have to do that again. But and I think that it's a question. I mean, I guess the question is and we need some feedback, right? Is, are people interested in working on this problem, whatever this this Yang model, whatever it might be, and are they willing to step forward and help, right? Because you're looking for more authors.
Could we also ask the question: is there anyone who would be looking to use this if it was published and implementations were available?
Richard Patterson again, as an operator, yeah, I'm absolutely want to be using this to model my BNGs and servers and stuff, along with the software models as well.
Would you be able to provide a review on that basis, just on what we've got at the moment? Maybe not necessarily what we've the stage we are at the moment, but I mean, if we were to do have the discussion about what we should include in the scope, and then produce an update at that stage, and would you be willing to review it based on?
Yeah, absolutely. Yep.
Okay, great. I mean, so as a proposal on what to do next, if we can see, what responses we get to anyone who would wish to join the authors list. Once we have that, I would suggest we produce a proposal about what we'll do with the scoping and put that on the mailing list, and then hopefully have some discussion around that. And based on the outcome of that, we'll produce an update and take it from there.
Yeah, maybe it's worth having whoever's interested sort of virtually meet or something to discuss.
Yeah, I think something like that would definitely be useful. Okay, I think that's everything that I've got in there. So thank you very much.
Okay. Thank you.
Okay, so let's talk about what's going on with DHC as a working group in general. Bernie, does it work? Yeah.
No.
Okay. Yeah, so I just wanted to recap what's the situation with the working group right now, and then I will move on to describe what the next steps could be. So this is the DHC charter. So in principle, we have 3 goals. The first one is work on informational documents providing operational and implementation advice about DHC PV6. So this is something that's ongoing. So we have the Yang models, we have the link layer assignment. There's also potential work of the with the Emery. Another thing in our charter is that we are supposed to assist other working groups in defining DHCP options. So, in my opinion, this is to some degree dysfunctional. I don't remember when was the last time we were requested to review a draft. There's some activity going on, but it's very infrequent. And the third thing that is in our charter is to issue an updated version of DHCPv6 spec. We did this, but there's a follow-up that after appropriate time we should work on promoting it to full standard. So this is in progress. So next. So these are the requirements to promote a draft standard to full standard. We are working on this. There are a couple technicalities that we need to deal with. The first one is there have to be at least 2 independent interoperating implementations. We are mostly there. We just need to confirm that the implementations are conformant with the update spec, not just with the base 2315. There are no major erratas that would cause new implementations to fail to interoperate. Currently, there are none. There are no unused features. We are also working on this. And the last one is related to IPR and patents. There are no patents reported at this time. So in principle, this looks reasonably good. The plan is that we'll wait around a year after the IETF104-15 was published. So it was published in November 2018. So around November 2019, we'll kick off the procedure to promote this to full standard. So, Jimmy?
Yeah, can I make a quick comment
Sure.
about this slide? I'm Jimmy Tatia. Regarding number 3, I think we should think about how to handle temporary IA temporary. I don't remember.
IETFs?
Yeah,
Mhm.
yeah.
The
Because
temporary-
in my understanding, virtually no one is using it, and maybe not greatly increasing the complexity, but I think it introduces some confusion about the interaction with other cases. So if we want to promote it to internet standard, then probably we might seriously think about deprecating it or making it more clear.
But I think TAs are already deprecated in 8415, right?
We still have them in there. I don't recall exactly what we said about them. I don't think we changed anything there.
Yeah.
Tim is coming up.
So I think we said that, they're not commonly used, but we didn't use the word deprecated or historical. So it's still there as something they can use. I don't think we recommended using it, but my memory of this is that we left it.
Yeah. So
We
does it
gave
mean-
words like this isn't common, but it's still here.
So does it mean that to claim full compliance, we have to implement it?
Oh boy. So
Uh,
when we've done this for other standards, like when we do interop testing, there are features that sometimes don't get. Not everyone supports them, right? That there's parts of the standard that just not everyone decides to do. It's still there. In some cases, we've in the past we get 1 or 2 implementations that might implement the thing, and we say we saw those guys work together. In this case, there's a lot of other IAs. I don't think this should be the thing that holds us up. Would be my. I would try to convince people that that's not a reason to stop this if we get everything else working. But
okay. Next slide. Yeah, so this looks like an action plan for the working group for 2019. So we still have some work to do. This is basically what we've been talking about today, or will be talking like with the MRE problem. So yeah, I think this is something that will keep us busy for this year. But what should we do after that? So next slide. So I just wanted to recap what's been going on with DHC. So this is the oldest working group, still operational. So it was created in the 80s. So yeah. So the recorded history is close to 18,000 mails, but we lost the history before 2001. So like there was more. Now compare this to RFC 2418. The working groups are generally expected to be short-lived. So this is short-lived if you are a geologist, okay? Otherwise, this is like a couple epochs. So yeah, so I think now would be a good time to consider what we should do with the working group next. So So I think we have a couple options. The first one is once we deal with the current work, we could recharter. But the question is what the charter would be. We could think about something like we have DNS op. So we could consider doing something similar, like creating a working group about DHCP operations. I don't know, maybe it would be more appropriate to do it in ops area, or maybe not do it in IETF at all. Maybe do it in some other bodies like in RIPE or NANOC. So this is one possibility. The other one is to put the working group in a dormant mode. So we wouldn't really meet. The mailing list would still be active. I think some people might get confused with this, but this is something that we can handle. And the last choice is to shut down the working group. So like, for example, happened with many other working groups, like Behave, for example. Behave is a good example because they shut down a couple of years ago, but the mailing list is active and it's still going. So if you open the link, there's active discussion about various things. So,
yeah, just to echo Suresh again with his AD add-on, so it supports going dormant after 8415 goes to full standard.
Okay. Yeah. So just to reiterate, we are not talking about doing this now, but within a year. So after we finish the current work and also promote to full standard. This also has a different nice side effect that we would have a deadline that people are working on current stuff. They know that they have a year to wrap it up. So, okay. So any thoughts, comments, suggestions? Any preferences?
Right, Tim Jones. So I think what we don't have here is a list of what is it that we think we might need to do. What are the requirements of a group if it continued? Once 8415 is IS, I think that's a very positive statement that it's out there, it's widely deployed and in use, and that's great. But do we want to do any more protocol work? Presumably people will define options in other working groups, and there needs to be some way of perhaps of those being reviewed. So you need some kind of review function. Is that possible in dormant state? Is it just something the AD could do?
I will add that, for right now, and I forget exactly what the text is, but, we do have a expert review process for both V4 and V6 options. And so actually, Ted
does that
Lemon,
require a working group?
Well, today there's no need to go to the working group to get options. So it's possible that, some other working group defines a draft that has options in it. We hopefully see those early enough that, we've commented on them and stuff. But sometimes we don't get them until they go to expert review. And at that point, that's the IANA process that when they get the document, as part of the last call process, they'll send it to the experts, which today are Ted Lemon, Tomek, and myself for the DHCP options. And so we will get notified, we'll look at it, and we either have to tell IANA, yeah, this follows the rules, or no, it doesn't. We need to work with them to clean it up.
And the other question would be if there are things we don't foresee that would normally fit in here. Again, Brexit language, we need a backstop. Would inter-area be a backstop for things that wouldn't be done here?
That's what I would think, is that we might do in-area stuff. Was probably the good place to put anything that does come up.
So I think if you're saying if there is a review function that exists already and we don't need to sort of vote things in here that are done elsewhere, and we can take things to inter-area, then I think setting, as someone else said, a deadline of a year to sort things out and then propose dormancy. I don't think you would go straight to shutdown, but move to a dormant state and see what happens. If suddenly things spring up, you can undorm.
Right. Or if nothing springs up, you say, hey, it's time to close it completely.
Yeah. So I think that sounds a reasonable approach.
So I think, you were in line, then we have Ian on.
Stephen Morris, ISC. Two things. One is follow the model of the TCP maintenance and minor extensions group, which focuses on correcting bugs in the protocol and then very modest extensions. And the other thing about shutting down the group is I would cast your minds back a few years when we had two DNS groups. We had DNS extensions, DNS operations, and DNS extensions. The working group chairs decided that's it. We're not going to enhance DNS anymore, and they shut it down. And now, if you look at DNS operations, it's operations and loads of protocol proposals.
Thank you. And let's get Ian.
Hello. So it's a bit noisy. Can you hear me?
Yep. Yes.
Right. Yep. I think there's an interim state between the two, isn't there? I mean, what we did in Softwire, and actually we've been hanging on like this for some time now, is just is not accepting new work and finishing the existing things that we have. And I mean, I think, you know, the idea of saying, well, taking the 8415 STD track and saying, well, that'll set the time frame for it. You know, from what I see in some work groups, you get times where there's a lot of stuff, times where there's less stuff. Obviously, DHC is in a lull at the moment, and you know, it may well be that this sign shows that it's petering out, or it may just be a lull that we don't know anything about. So saying specifically anything more than a statement of this is how we're going to proceed, or this is how we expect us to proceed, seems a little premature for, you know, a decision that doesn't need to be taken for a year yet. But assuming this lull continues, then what about saying after N months, 6, 9 months or something, that you just close to taking new work on, you carry on with you know, finishing whatever is done in there, and talk about moving to a whatever DHC ops or DHC EXT or whatever else it happens to be.
I mean, personally, just to comment on Ian, I don't think, you know, I'm not sure we'd want to set up a new working group that basically takes on what the old one did, right? I mean, so.
Yeah, but I mean, you've always got this problem then of what happens to any new stuff that comes in, because, you know, saying that protocol is complete, finished, and will, you know, that's almost certainly not going to happen, is it? There will be new things that will be needed. We don't know necessarily what those are at the moment, so we need a practical way of being able to handle those.
Okay.
Shane Kerr. I just want to caution against using a comparison with the DNS space here, because in DNS, there was a long period where new development was basically suppressed in the IETF in order to focus on DNS security. And once that completed, there was a lot of interest in new developments and new technologies. Plus, the technologies continue to evolve, not super rapidly, but they do continue to evolve. So I don't know that that we need to be too worried that the same thing is going to happen in the DHCP space. So.
Eric Green again for Suresh. Basically says to Tim, yes, this will be the backup plan.
Okay, so any other comments? I don't see anyone. So yeah, I suppose that's it. So we have the plan laid out, and
yeah, and it may end up changing based on what happens between now and then anyway. Yep. You know, so it's just sort of you know, we just wanted to sort of open the discussion to see what people were thinking at this point in time that we should do. And you know, our again, the main goal over the next year will be to or even less, is to advance 8415. So anything that people can do to you know, help with that, which is basically to confirm that, you know, existing implementations adhere to the requirements of that document. You know, they currently adhere to the 3315, 3633 and stuff like that, but there were some not significant changes, but there were some minor changes made to sort of pull all the work together, and so we need implementations that are really closely following 8415. All right. I think with that, we'll go to the multi-extensions.
Hello, everyone. Hello. Hello, everyone. My name is Lin He from Tsinghua University. Today, I'm going to introduce our draft problem statement of multi-requirement extensions for DHCP v6. And I will first introduce background and current extension practices, and then explain where we can extend DHCP v6. And finally, we will give an extension case. IPv6 address generation is closely related to the manageability, security, privacy protection, and traceability of the networks. DHCP v6 can be extended by new options, messages, and protocols. Some DHCP servers software provides interfaces to allow for user-defined extensions. Some people may suggest that we can modify open source DHCP servers to do the job. However, it is very difficult, and we need to maintain the code, and so we need a general insight of how to solve the extension problem better. Currently, we have three extension cases. The first one is to extend options. This is the most common practice. And the second one is to extend messages. For example, Actively Query provides query messages to allow administrators to extend the DHCP server. And the third one is to extend entity. For example, Radius server is introduced into DHCP to conduct authentications. For DHCP server implementation, Cisco CPNR provides extension APIs to allow administrators to extend their DHCP server. Kia DHCP provides hook mechanisms to do the same job. Here we summarize a DHCP general model, which includes several parts. DHCP entities, that is clients, relays, and servers. DHCP messages with options, and the message processing functions, and address generation mechanisms. Next, we will introduce where we can extend the DHCP v6. That is DHCP messages, options, and message processing functions, and address generation mechanisms. We will introduce each point from the status, problem, and the possible solutions. Let's say DHCP messages. Currently, we can define new messages, but all DHCP messages are in plain text. That is, there is a lack of privacy protection on messages. RFC 7824 provides privacy protection, privacy considerations for DHCP v6. We think one of the most possible solutions is that we encrypt all the DHCP messages. Next, please. The second one is the options. Currently, we can define new options to carry new parameters. For example, vendor-specific information allow us to define new sub options to serve our private purposes. But some parameters may come from users. That is to say, these parameters are uncertain and may change. We think there are two kinds of possible solutions. The first one is that clients provide interfaces to obtain user parameters. However, there are few such interfaces. The second one is that relays obtain the new parameters first and then add them into DHCP requests. However, this needs the support of other protocols. A third one is that is the message processing functions. Currently, some servers provide interfaces to allow for user-defined extensions, and this customize how servers handle and respond to the DHCP requests. However, not all DHCP software considers this extension. We think DHCP server may support user-defined extensions. Next, please. And the last one is address generation mechanisms. Currently, there are many IPv6 address generation mechanisms, and DHCP servers usually generate random IPv6 addresses. However, different networks may need different address generation mechanisms due to the different requirements. So we think the possible solution is that to allow user-defined and different address generation mechanisms to be configured. Next, please. Here we conclude some two extension principles. The first one is do not change the current DHCP general model. The second one is to use the simple interfaces to define and support the extension. Other new principles can be added in the future. Next, please. Here we present, we give an extension case which is published in IEEE Infocom 2019, and considering such a requirement that IPv6 addresses are generated from user identifiers for accountability and privacy, and we have to do two things to achieve such a goal. The first one is that clients send their user identifiers to servers. The second one is servers generate addresses and assign them to clients. However, this needs the help of other protocols. We are wondering if the DHCP is more extensible, so we can do it better. Next, please. With thanks the changes compared with 0, with thanks for Bernie's valuable comments, and we'll address them in the 01. Next, please. We are not sure DHC's working group is interested in this work. So, any comments? Thank you.
And again, currently this is an individual submission, and I think it's on the informational track, right?
Yeah.
And it basically just outlines, you know, these different options that people have, and you know the hook points and extension points that some of the servers provide that let people perform or let system administrators perform more complicated tasks or customize certain aspects of the processing for their usage. So it's just useful, I think, information for people to be aware of, that these hooks do exist, so that, you know, when you have more complicated requirements, that you could meet those without necessarily having to go and change the protocol or request, you know, new features.
Tim Chan, yeah, I think this is really useful, particularly if we are sort of winding things up and going dormant, to publish best practice on how to minimally extend things without requiring big changes. I think it's a really useful document to have. So let's get consensus on it and publish it.
Thank you.
I'm Darren from Tsinghua University. Currently, many research works have been done to improve the internet accountability and privacy. Most of these works are related with IP address configuration and generation. I think as one of the main protocol related with IP address configuration, I think it may be useful to make some extension to support multiple requirements more easily.
Thank you.
So, Tomek Mrugowski here. So, from my perspective, in principle, all of the information is already there, but the biggest value of this draft would be to have it in one single place. And it would be a good reference point for people that want to do something uncommon point them, hey, this is your static point. So yeah, I'm in favor of this draft, of adopting it if we go that route.
Thank you.
Francis, you can put slide 11, where there are the reference. No, the one with this one. The paper, it's a reference. It's not yet published. It's the Infocom conference is in May this year. So, say because if you want to read the paper, you have to wait or ask him.
Any other comments?
Oh, you can ask.
Oh, thank you.
Okay, so it seems that the logical next step for this would be to initiate adoption call. So, but before we do that, so can I see a raise of hands for people who think that this is a good idea and would like to support it? Okay, so there's quite a few people. So yeah, that's good. So we'll go with adoption call. Just keep in mind that your support should be restated on the mailing list. This is essential. We cannot just say, well, there were some guys waving hands and we adopted. Okay, so that was the last item on our agenda. So I suppose we are done. So blue sheets, who have blue sheets? If you haven't signed them, please do so.
Yeah, and anybody have anything else for us? And otherwise, we'll see you sometime soon. Probably, for the next step will be the 8415 full standard steps. So I guess it's the internet standard. They don't do full anymore. Thank you. Done.
Hey, it was live.